Dear student, welcome to the next part of application of partial differentiation, that is unit number 3 of engineering mathematics 1. In this video we will discuss property number 2. Before you watching this video, I am going to my channel and please subscribe my channel and click the bell icon for you have to get the new notification of new video. Okay, in this video we will start the next property, that is property number 2. See the statement of property 2. Okay, in this statement we have to given if u and v are the function of r and s. Okay, look, see carefully. If you if u and v are the function of r and s, where r and s are the function of x and y, it means that you have to given firstly uv function of r and s, then again we have to given r and s is the function of x and y, then we have to find the value of del of u comma v upon del of x comma y. How to find this value? Firstly, we differentiate uv with respect to rs. I am writing here del of u comma v upon r comma s and multiply by, again differentiate r and s with respect to x and y. That's why I am writing here del of r comma s upon del of x comma y. Okay, this is a property number 2. You can simply say this property is a Jacobian property. Okay, this is not a proper name of this property, but we can understand by the help of chain rule property. Okay, because we have to give one function in terms of firstly u and v, again r and s and xy. Okay, so see one more numerical example about this property. Next, in this question find the value of del of x u comma v upon del of r comma theta, where u is equals to x square minus y square and phi is equals to 2xy, and x is equals to r cos theta and y is equals to r sin theta. In this question we have to given u is a function in terms of variable x and y, also phi is a function in terms of variable x and y, and again x and y in terms of function, and in this function r and theta are the variable. So we have to find the value. We have, firstly, how to solve this example step by step. First, right here we have to find, simply we have to given that we have to give one u is equals to x square minus y square and phi is equals to 2xy, and x is equals to r cos theta and y is equals to r sin theta. Okay, now find the value of del u comma v upon del of r comma theta. Look at here, simply we have to given information u and v in terms of variable x and y, and x and y is the in terms of variable r comma theta. Then above we use above the statement, above the property. This property says that you have to give one function x and y in you have to give one function u and v in terms of x and y, and x and y in terms of r comma theta. Then firstly we differentiate u comma v with respect to xy, and again differentiate xy with respect to r theta. So I am right here, firstly differentiate u comma v upon with respect to x comma theta, multiply by differentiate again x comma y with respect to r comma theta. Okay, what is the meaning of this? Meaning of this term is Jacobian of two function. Okay, so I am right here. Now find del of u comma v upon del of x comma y, which is equals to in determinant of del u upon del x, del u upon del y, and second row del v upon del x, del v upon del y. Okay, which is equals to, okay, what is the meaning of this? Del partial differentiation of u with respect to x. What is u? U is equals to x square minus y square. So partial derivative of u with respect to x is a 2x. Similarly, 2y. Okay, now second row, what is the meaning of this? The meaning of this term is partial derivative of v with respect to x. What is v? V is equals to 2xy, so derivative is 2y, similarly 2x. Okay, now solve this determinant. 2 into 2x is a 2x square, and minus 2y into 2y is a 2y square, sorry, 4x and 4y. 2 into 2 4, y into y square. Similarly 2 into 2 is 2, and x into x is x square. Next term is taking 4 is common, remaining is x square minus y square. Okay, look at here, x square minus y square in terms given in the u is equals to x square, so I am writing here 4 into u, because u is equals to x square minus y square, so I am writing here x square minus y square, replacing by u. So del of u comma v upon del of x comma y is equals to, we have to get a 4u. Now next term is find del of x comma y upon del of r comma theta. So del of x comma y upon del of r comma theta is equals to, in the determinant of del x upon del r, del x upon del theta, del y upon del r, and del y upon del theta, which is equals to. Okay, now what is meaning of this? Partial differentiation of x with respect to r. Okay, x is given, x is equals to r into cos theta. We have to differentiate partially with respect to r, so derivative is only cos theta. Next, derivative of x with respect to theta, x is r into cos theta, so derivative of r into cos theta is minus of r sin theta. Similarly, partial differentiation of y with respect to r, y is given r into sin theta, so derivative is sin theta, and derivative of y with respect to theta is r into cos theta. So solve this term, r into cos square theta minus, and this term is minus minus, plus r into sin square theta. Okay, look at this term, taking r common, remaining is sin square theta plus cos square theta. Everyone knows sin square theta plus cos square theta is 1, when 1 into r is r. Okay, del of x comma y upon del of r comma theta is equals to r. By the above property, we have to say this is equation number 1, so I am right here, from equation 1 we get del of u comma v upon del of r comma theta, which is equals to del of u comma v upon del of x comma y is equals to 4u. Okay, multiply by del of x comma y upon del of r comma theta is equals to r, so I am right here 4ru. This is a final answer, 4ru. Okay, 4 into u into r is a 4ru. Okay, thank you student. I hope we have to understand this property number 2 and one numerical example. Thank you student.